It's really easy. Food is sitting out and touching the air. The heat from your food's not disappearing. It's being transferred to the air. Because heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold.
Please do not forget to rate yourself. I've only got 2 people who have rated their understanding so far.
What happens? It's really simple. Your body has a warmer temperature because once you use the cooler water, it's taking your heat energy for sure. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold. Cold, from hot to cold. Thermometer is a tool we use to measure heat and measures particles movement. They're moving endlessly. When molecules gain heat energy, they move around faster. The liquid expands and the temp goes up on the thermometer. Cause heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot to cold. Heat transfer is really neat. It always goes from hot to cold, from hot to cold, from hot
All right,
to cold.
Jaden, Genesis, I'm looking for you guys to check in. Isaiah, you could be with Miss Telfont right now.
Have the same temperature. So
Thank you, Colin, for checking in. Lee, I'm looking for you to check in.
It takes energy easily.
Rate yourself. How well are you understanding?
We call these insulators. They don't conduct energy that well, so I'll see y'all later. Heat transfer is really neat.
And don't forget, you can always message me privately if you don't want everybody to see your score.
Heat transfer is really
Song coming
neat.
up. Let's
It
get
always
checked in.
goes from hot to cold, from hot to cold, from hot to
Takeda?
cold.
All right, the song is over, so that should mean that everyone is checked in. Thank you so much to Fumi, Josiah, Haley, Asia, Jacaden, Cullen, and Genesis for checking in. Thank you very much. Excellent. So it's looking like heat transfer is something that many of you are understanding very well. We're missing a couple of our friends this morning. Before we get started, I don't want them to miss out on the cool experiment that we're going to do today. So let me send them an email very quickly. So I'm going to stop sharing real quick. Well, oh, Jamari, I didn't see you come in this morning. All right, I'll go ahead and mark you down. All right. Give me just a moment. I guess I could be doing this since Fumi was helping me admit people. That could be kind of like you guys check in and I have one of you helping admit people, and then we do things that way. That'd probably be best. Okay. Oh, Aisha, I didn't mark you off earlier. All right, Jaquel. Waylon's missing science. Waylon, Samantha. Mackenzie. I don't really see Mackenzie. Oh, didn't mark Fumi. Make sure there's no one that I did. Okay. All right, guys, while we're giving them just a minute to join us, We're going to go ahead. We're going to get started with some review of what we learned last week. So don't forget, on Thursday and Friday, you should have submitted a total of 3 pictures to me. You should have submitted 1 picture of conduction. You should have submitted 1 picture of radiation. And then you should have submitted 1 picture of convection. So some of you might be thinking, because it was the weekend and we tend to turn our brains off over the weekend, you may be thinking, oh, what are those things that Ms. Hernandez is talking about, convection and radiation? So we're going to review the 3 types of heat transfer together. Just a moment. Find my slides. Who was that who just came in? Yay, Nellie. Been missing you. Okay. All right, so remember, heat always moves from hot to cold, from hot to cold, from hot to cold, but it can move in 3 different ways. We've got conduction, convection, and radiation. So today I'm sending happy mail to the students who have completed all of their science assignments for me so far. So I would love to put an extra little something in your envelope, or send you something if you're not already getting something. I would love to send you a little treat. If you can tell me what one of these are, you may raise your hand or comment in the chat box. Whoever answers first for conduction gets a conduction treat for me. I do have Diet Coke. I got Mentos too. Wham! Anybody? Oh, Nellie. Tell me one, girl.
I can't find my mic. One of these is conduction. Conduction is basically like, say you have the burner on and you touch the stove. That makes your hand get burnt because you touched it, and the heat is going from the stove to your hand, so it makes your hand feel really hot.
That is exactly right. Yes. So we have conduction, and that is heat being transferred through direct touch. So that could be you touching a hot burner or a hot curling iron curling your hair, because it has to touch it in order for that to happen. But remember, it could be something as simple as you setting your bottom in a seat and heat transferring from your body to the seat and warming the seat up.
Ms. Hernandez?
Yes.
I have another thing of conduction.
Okay, yeah, go ahead.
It's like, say, you have your desk light on, or like you leave like something out in the sun. The heat is the thermal waves going from the sun to the pan or thing that you have outside or the desk, and it makes the object go warm because of the heat energy that's being from the desk lamp to the desk.
Yes, excellent. That is absolutely correct. Is it because the lamp is getting warm? Or is it from the light of the lamp warming the desk?
The light of the lamp warming the desk.
Okay, so that would not be conduction.
Oh.
It's not because of the lamp, the warmth from the heat of the lamp that's just touching the desk. It's actually going to be radiation, because the warmth of the light from the lamp is warming the desk without actually touching it. But yes, that's an excellent example. Who can tell me what convection or radiation is? I've got 3 people with their hands up. Cullen. By the way, Nellie, I'm sending you something special in the mail.
Wait, conduction?
Nope, I'm looking for convection and radiation
now. For convection, let's say there was an air vent. It would be. I'm just gonna do radiation because I'm not well at convection.
Okay.
So for radiation, if you have a microwave and you heat something in it like macaroni, mac and cheese, it would heat it up because of the electric waves that would make it heat up
Yes.
from the metal inside of it.
Yes. So radiation is heating through electromagnetic waves. So without actually touching it, but the waves heating up your food, and the waves could come from the microwave or from another source. I'm not going to reveal that source because I want to give Asia and Genesis an opportunity to share so that they may get a special something in the mail today. Asia, can you tell me convection or another example of radiation?
I do another example of radiation.
Okay.
Maybe if you're outside and you're playing with your friends and you're playing tag or something, and then the sun just bothers you because you get hot, because the sun transferring to your body without touching the sun.
Yes, excellent. So the heat from the sun is transferred to your body, gets you really hot and sweaty, but thank goodness the sun does not touch you because that would be conduction, and you would die. But yes, so the sun's heat radiating from the sun to warm us up. Absolutely. Excellent job, Asia. And last but not least, Genesis, can you give us an example of convection?
Yes, convection, so say if you're in your room with the fan on, like you're freezing cold, like really cold, you have it like all the way at, not, oh my gosh, I can't remember what I was gonna say, but full blast, and it gets you like really cold, and you like cut it off, and then you're like, oh dang, I'm hot again. Then you're gonna cut it on. Then, oh no, I'm cold. Then you're gonna cut it on. I'm hot now. Then you're gonna just do it again.
Okay, so excellent. So an air conditioner is definitely an example of convection currents. And remember, convection currents are when the air or water heats up in a current. So what's happening is the cool air is being pushed to you. So the air is cooler than your body. So what actually happens is the heat from your body is transferred to the air around you, which then makes you cool down. And then, like you said, you turn the air off and the temperatures between the air and your body start to get even again. So you start to get hot. So again, you turn the air back on and the process starts all over again. Anytime the air is cooler than you're going to be transferring your heat to the air around you. Which helps to cool you down. If the air around you is hotter than you, then that's going to warm you up because the heat is going to be transferred to your body. Excellent job. Just remember that convection currents, and thank you for that. Remember that convection currents are moving in currents or cycles, okay? They keep going around and around and around. All right. Looking to make sure I'm not missing anyone. All right, and then rejoin. Okay, so this is our project today, but I'm going to save this to share with you after the quick little experiment that I want to do with you all. So as we start our project, you all are going to see that there are what are called conductors and insulators. And you're going to learn more about that tomorrow and through the rest of the week. But today, I'm moving everything out of the way so that we are safe for the experiment, because we are going to be utilizing an open flame today for our experiment. I'm going to turn my light down just a little bit so we can see. Okay. So I want to make sure that I keep my electronics and everything away. I'm also going to tie my hair back because we are using open flames for the experiment today. And some of you may have seen this experiment being done on TikTok, so please do not share what you know with your classmates. And then Jamari has reminded me, like a good scientist, that I should always wear my safety goggles when I'm conducting an experiment. especially one with open flames. All right, so now we're ready. Got my lab coat on, got my safety goggles, and my hair is pulled back because we're about to get crazy up in here. Okay, so some of you have maybe have seen this experiment on TikTok if you're a TikToker. So don't share the secrets, but I have 2 balloons with me today. One of those balloons has water in it. You guys can see the water there. And one of those balloons is just full of air. There's nothing in this one, it's just air. So first of all, I would like to get some predictions in the chat box because I can't see the participants right now because you guys are on my computer. What is going to happen here when I put this balloon over the flame? And I'm going to have to stand like this so you guys can see the flame. What's going to happen? Oh, Waylon says it's going to pop. Oh, I see. Oh, Cullen says it's going to explode. Anybody else? It's going to pop. Anybody think the balloon's going to catch on fire? No, we're just lots of popping. Jacaden thinks it's going to pop. All right, here we go. Let's see what happens when we put the balloon over the flames. Ah, I put the flame out. Let's try this again. Maybe I'm a little nervous. All this talk about popping balloons scares me. Popping balloons makes me very nervous. All right. This one's almost burned out. We'll see if it works. Here we go. Oh, yep, you were right. It popped. And it blew the candle out. So luckily I've got some others on standby here. All right, now we're going to try the balloon with water in it. Now, those of you who have seen the TikTok or the YouTube video, don't spoil it for the others. Oh, Genesis told you. Yes, I was very nervous, very nervous. Okay, so we've got another flame here burning. And I have a balloon with water in it. You see the water? What's going to happen when I put this balloon with water in it over the flame? What is going to happen? It did explode. You didn't see it explode? Uh-oh. So Lena thinks that it's going to pop and the water's going to go everywhere. It's not going to pop. Genesis thinks the water is going to spill. Any other predictions? What's going to happen when I put this balloon? It's going to go out. So we might have a mess. There might be a good reason why my computer is away from the lab experimentation table. I made that word up, experimentation. All right. Oh, it's going to heat up like radiation. Ooh, I absolutely love that Jamari has noticed that since we're playing with fire, or experimenting with fire, that we are using radiation. Whoop, whoop. Extra points for Jamari. All right, let's see what's gonna happen. Gotta take some deep breaths. Popping balloons scares me. Here we go. All right, we got the flames touching the balloon. You guys see that? The flames are on the balloon. I don't know if you guys can see that. Let me turn my light up a little bit. Maybe it's too much light. Let's try it now. Let's see. Can y'all see it? Watch this. Do y'all see it? The balloon's getting black on the bottom. The soot from the fire, like I'm literally, it is in the fire. And the fire is radiating heat to the balloon just like it was before. However, since we have water in the balloon, what's actually happening You guys can't feel it, but I can. The water is actually heating up. We are heating up the water inside of the balloon. So what happened? Oh, and I'm getting soot on my hands. So what happened the first time is the air is not a good conductor of heat. So when we put the balloon over the fire, all the fire's heat went to the latex and exploded the balloon because air is not a good conductor of heat. It's actually an insulator. However, water is an excellent conductor of heat. And what's happening when we put the balloon with water in it over the fire, all of the heat from the fire is being pulled away from the latex and into the water. So if we had enough time here today, guys, we could actually boil the water in the balloon and it would not bust. So that's really cool. But we don't have time for that today. So keep that in mind as you are thinking about conductors and insulators. Remember, conductors pull the heat energy through very easily. Insulators do not allow the heat to pass through easily. So the air kind of stopped the heat and it just burnt the latex and everything blew up. However, when we have our water in here, since water is a good conductor, it pulls all the heat to it. So keep that in mind as you're deciding what type of animal shelter you might be creating, and you guys will learn more about that today after you watch our entry event for your lesson. And for our next project, which I'm going to talk about, so let me go ahead and share my screen here again so that we can talk about our project, and then you guys can go on your way to completing your science assignment. So this is what it's going to look like in Echo today, except you are not going to see the video here. You're actually going to have to click the link to see the video. It's called Cold Cats and Hot Dogs. So after watching the video, and I'm going to tell you a couple things about conductors and insulators and thermodynamics, you're going to complete the Nearpod lesson. There's also a video in the Nearpod lesson that you need to watch. And then you're going to fill out your knows and need to knows before we start the project. So knowing that we're going to be creating an animal shelter for a cat or a dog that can stay warm in the winter or cool in the summer, I need to know what you know about heat transfer that you can apply to making your animal shelter. Also, what do you know about animals? What do you know about how they like their homes to be? Think about those types of things before you start the project and add them to the collaboration board. Then you're going to skip over to the need to knows. What are some things that we need to learn or we need to know in order to be able to build an effective animal shelter that can keep animals warm in the winter and cool in the summer? And if you guys don't have any questions, I hope you have enjoyed science today and you are free to go. If you have any questions or just want to hang out and talk to me for a couple minutes, you're welcome to stay. You do not have to leave. But if you're ready just to go ahead and get started, to watch the entry event, super cool video that me and Mr. S made, you are free to go. I love you bunches. Mwah, mwah. And I'll be here until probably about 11 o'clock. If you need to hop back on, have any questions, or you just want to let me know something after you've watched the entry event and completed your assignment today. Bye, guys. Mwah, mwah. Love science.
Ms. Hernandez.
Yes, ma'am. I was looking for you today. I was like, where is Laylan? I know this girl is not missing science.
So today I actually love science so much to where now